Okay, welcome. We're going to make this as a concise review for the last exam, and I hope that you guys find this clear. If you have questions at the very end when I turn off my recording, you feel free to ask me questions. But um, we're going to go over every type of problem, and then if you study this and kind of use this practice exam, which I sent you earlier, maybe it was way earlier this evening, I sent you this practice exam. It should familiarize you with every type of thing that's on the test. Okay. So without further ado, let me move some things out. Oh, I have to change something here. Sorry, letting people in the classroom. All right. So the first type of problem that we're going to talk about is this. The first couple of practice problems here are conversions, okay, where we're converting one type of measurement to another. You may vaguely recall that we went over this a couple of weeks ago. And so just to give you the heads up, in your notes, um, I kind of prepared you with some charts, that you could use so that you would be able to calculate when you're moving from smaller to larger or from larger to smaller, depending on what the operation happens to be. And so with that in mind, let me see if I can get my pen thing here to work here, folks. Um, okay, start drawing. Yep, there we go. Okay, so we've got a question. It says using figure 1. Okay, so first of all, what you will have is you'll have some charts at the back of your test that you can scroll to. And actually, for your class, if I recall correctly, yeah, I actually put the chart right into the question. So you don't even have to, when you actually take your third exam, you shouldn't have to look anywhere scrolling. It'll be right there, okay? But it says convert 5,550 grams equals how many kilograms, okay? So in this case, grams, kilograms, we're going from smaller to larger. Now, how do we know this? Because if we look at the chart, this figure, okay, figure 1, we would see that 1 kilogram, okay, that one of these, okay, is worth 1,000 of the grams. Okay, so 5,550 grams, one of the kilograms is 1,000 of them. Okay. Um, and so if we take and we divide, so every time you're going from a smaller unit of measurement, the grams to kilograms, seems like that seems backwards to me. It may be. Um, then you divide. So you got 5,550. If I divide it by 1,000, because there's 1,000 grams in every one of the kilograms, we're just setting up the chart. Just to remind you, we've got the grams here. They're asking how many grams, okay? Um, and this probably should be kilograms here. I can see that there's some problems on this thing, okay? Equals, yeah, the kilograms to kilograms, grams to grams. And so if we divide 1,000 into 5,500, you get 5.5 or 5.5 kilograms. Okay. So again, the rule is, and you might recognize this if I kind of do this thing here. In your notes, we had a chart and we said, set up a chart and determine if you're going from smaller to larger. And how will you determine that? You'll look at the chart and see which unit is larger, and then look at what they're asking you here. Are they asking you some grams to kilograms? This seems backwards. I think a kilogram would be 1,000th of a gram, but maybe I'm messing that up. All right, so I'm going to move on to the next one. I'll change color just for the sake of it. It says using figure 1, convert 17 meters to centimeters. Okay, this one I know is correct. So meters, a meter is like, 100-meter dash. Centimeters, there's like 100 centimeters in every meter. So I know that this is, I'm going from meters, okay, to something that's smaller. This is a larger unit of measurement, okay? And so we're going from larger to smaller. You just set it up like this. Sorry. But just by looking at meters to centimeters. Okay, we're going from the larger unit to the smaller one. And you can literally, on your scratch paper, you can write that out like that. And then we could look up on at the chart. I'm sorry, the question itself asks is 17 meters. Okay, that's this up here. Okay, is how many centimeters? They want to know how many centimeters. We look at our figure 1 and it says that 1 meter is 100 centimeters. Okay, and the rule is that when you go from larger to smaller, you see the first word larger. How do you make something larger? You times it, you multiply. Okay, that's the rule. So that's my little hint. So if you're looking at larger to smaller, larger means to multiply. Yeah, that's the rule. So if I take what's left, I'm going to look at my numbers here. And this is what we did in practice in class here. Okay. Look at what we have left on our chart. Okay. So what do we have to multiply if we go like this? Okay. We know we don't multiply the question mark, and we know we never multiply the 1. Okay. One of these equals how many of these? So what's left? 17 times 100. So 1,700 centimeters. Okay. So if you're going, oh man, it's been a while since I've seen that, it's a little bit fuzzy, go back to the notes, look at your notes, and we really laid out some examples of how to do this. And that's just converting larger to smaller, smaller to larger. Okay. What I'm going to do is I'm going to scroll down to question number 3 here, and I'm going to clear all my drawings. Okay, hope this is okay. Scroll down to number 3. I'm going to talk about that. Okay, I think I'll scroll all the way up here. Let's see here. Okay, so question number 3 asks us this question. It says, if there's exactly 2.54 centimeters in 1 inch, centimeters to inch, okay, how many inches are there in 5 centimeters round to the nearest hundredth? All right, so what we've set up is a ratio, okay? We've got ratio number 1 here. 1 inch, okay, is 2.5, and this is the inches, okay? 1 inch is 2.5 centimeters, so cm for centimeters, okay? That's a cm, okay? And then it wants to know how many inches, okay? How many inches, it's right here in the question, how many inches, so that's my x, okay, are in 5 centimeters. This is the 5 centimeters that goes right down here, okay? So what we've set up is a proportion. 1 inch to 2.5 centimeters is the equivalent to how many inches to 5 centimeters, okay? And then, if you recall, we can cross multiply to find the x, okay? We can set it up like this. We'll go 2.54 times x equals, let's cross multiply the other two, 5, okay? And then if you recall, if you're trying to get x by itself, okay, if we divide both sides by as an algebra problem, you've got 2.54x equals 5. To get x by itself, you see how these two are multiplied by each other? To get x by itself, you do the opposite operation. So see how they're side by side, that means they're multiplied. The opposite operation is to divide by 2.54, okay? And what that does, if I change colors real quick here, is that cancels out the 2.54s and you just have x, okay? But whatever you did to the left side of the equal sign, you have to do the same thing to the right. And that's what this is right here. This is 5 divided by 2.54, okay? Which you can punch in your calculator and you'll get 1.968, okay? Which rounds up, by the way, it says to round it to the nearest hundredth, okay? This number right here is in the hundredth place. 10th, 100th, 1000th, 10th, 100,000ths. The number to the right is 5 or more, so it becomes 1.97, and that's why this answer says 1.97. Okay. So again, if they're asking you to solve for an x, we can set up a ratio. We can set up a proportion. Inches, if centimeters to 1 inch, that's what we have on this side. So we do centimeters to the other inch, and we can solve for it. Okay. Let's see here. I think I want to look at number 4 here. Using figure 2, by what percent did the home prices in King County increase from 2000 to 2005? Okay, as I previously mentioned, I think in the actual question, you'll have the chart, the figure, okay? And so here's what we found out um, from 2002 in the chart. I'm not going to scroll to it or anything, but in the year 2000, the cost of a house was 300,000. Okay, this was in the year 2000. Okay, by 2005, the cost of a house in King County, which is what this is about, King County, was 450,000. Okay, that was 2005. So what I'm going to do is I'm going to put a box around that so you can see those go together. Okay. All right. So in 2000, they were 300,000, 2005, 450. They went up a lot. Okay. So in your notes, if you're taking notes, you also have this in your notes, the formula for figuring out calculating the percent change. Okay. Okay. Is, if you want to write this down, okay, it's your end value, ending value, which I think, what do they call it in the book? They had another name for it. Minus your starting value, which is the initial value, is another name for it. Okay. This is the formula. So be sure and write this down. This is for calculating what's the percent change. Like if people lose weight, what percent did they lose? Okay. You do that calculation first. Okay. Our ending value, as it's showing on this little answer cheat sheet here, is we had 450,000, 4,500 per house. That was the ending value in 2005. Starting minus the starting value, which was 300,000, and we get an answer. Okay. And that answer is divided by your starting value. Okay. And that's the formula. Okay. So again, you should write this down. This is your formula for, come on, pen, um, for calculating percent change. This is for percent change. If you want to add that to your notes, okay? All right. So there's my formula. I just have to write that down. You can use it on the test, have that notes with you, okay? The formula for percent change is you take your end value minus your starting value. You're going to get an answer first. Do that first, okay? Take that answer and divide it by your starting value. In the numbers that I've given you as the answer here, any value was 4,500 per thousand, 450,000 per house. So we subtracted those two, we got 150. Divide it by the starting value, which is 300, and we would get probably 0.50, which is 50%. So on your calculator, it would probably say something like this: 0.50, and to convert that to percentage, you move it two places. A 50% increase. Okay. Now, there are a couple of these like this on your practice exam. A couple of questions that are just like this. So just be aware of that in every single case, literally, when you're calculating percent change, okay, you're going to use that formula. So if they ask you for percent change on something, use that formula, okay? I'm looking at number 4, that we did. 5 and 6 all have to do with percent change, okay? By what percent did the home prices in King County increase from 1970 to 2000? Same exact formula, okay? Ending value minus your starting value. Okay, all of those are the same. Now, that brings us to number 8 here, which I want to stop and look at because it is very similar to one of the questions on your exam. And so I want you to feel like, okay, I got this concept. Okay. So let's take a look at that one. And I have to apologize because the PDF kind of moved things a little bit here. But so if this really helps here, I'm just going to do this. You may want to do this if you printed out your practice exam. Okay. Um, and then, in fact, if I change color, it kind of helps to kind of categorize your ending weight. Okay, is this, okay. And then your amount that you lost, and weight, pounds lost is this here. Okay. All right. So there's my pounds lost. That was a 36 there. All right. So what it's going to give you on the test is Oliver and Jamie are working together to lose weight. After the first month, they weigh in and compare their results, fill in the table round to the percent to the nearest tenth. I'm going to model again for you whenever they say something like that at the end of the question. If you have a paper copy in a class, highlight or underline that, maybe put a big star by it, reminding yourself, hey, I'm supposed to do this at the end, okay? And that will give you a higher chance of not forgetting something. All right, so what they're going to give you on the exam, and they often do this in story problems, is they'll give you Oliver's starting weight was 280 pounds. His ending weight was 244, and that's all they're going to give you. And they're going to want to know what percent did he lose of his original weight. Okay. Same with Jamie, starting weight, ending weight. Okay. What you're going to do is we're going to subtract these two, which is real similar to what we were just talking about. Okay. Subtract these two, you get 36. Okay. Oliver lost 36 pounds. If I divide that 36, okay, can you figure out right now by what would you divide the 36 by? Remember their formula? Ending weight minus the starting weight. Okay. You're going to divide it by the starting weight. Okay. So in this case, if I kind of draw a little arrow here to show you how we got this 12.9%, okay, as an answer. These are a little bit bolder. You see how these are the answers. You would not see these on your exam, okay? All right, so if I did 280 minus 244, I'm gonna get 36. He lost 36 pounds. 36 divided by, okay, his starting weight, which is starting weight. It's over here, 280. 280. Okay, I'm going to punch that into my calculator in a matter of seconds. 36 divided by 280 equals, come on. Yeah, it's 0.1285. So equals 0.1285. Okay. All right. That's what you'll get on your calculator. Okay. Following that formula, divide it by the starting weight. When you subtract the two, you get a number and divide it by the starting weight. All right. Having said that, you guys know how to convert this 0.125 to percentage by moving the decimal point 2 places, and that gives you 12.85. Okay. And then we go back to what the teacher said. Oh, it says to round to the nearest tenth. Tenth. You see the tenth there? This right here is in the 10th place. This 8 is 10th, 100th. There's no 1th place, okay? The next number is 5 or more, so that's how it became 12.9, okay, percent. And that is what it says right here, 12.9%. We'll do the same with Jamie and any others. We go starting weight, ending weight. Subtract the two, she lost 15 pounds. Divide the 15 pounds by her starting weight, 190, and that'll give you 7 point, maybe 8 something, which with a number that's 5 or more, rounding up to 7.9. Okay. All right. I hope that was helpful. All of those are really using the same formula, which is the formula for percent change. Moving to number 9, identify the factors in the following equation. Factors are, okay, just to kind of remind yourself here that when you're talking about factors, you're talking about things multiplied by each other, okay? If that helps you to remember, those are multiplied. Come on. Okay, so they want to know all the factors. What are the things that are multiplied together, okay? Well, I had mentioned previously that I've got negative 7y. These two are multiplied. If y was 4, it'd be negative 7 times 4, which is negative 28. So these two are multiplied, okay? So over here, your factors would be negative 7. I'll rewrite it here, comma, which is telling the teacher, okay, here comes another one. Y is a factor, comma. What else is multiplied? Not 2, but 3 and y are. So it's 3, and if you want to be really thorough, you could say y again, okay? Those are the 4 factors. Now, technically here, it's really negative 7y and 3 because y is a factor that's twice here, okay? But those are all listed here. So negative 7y and 3 and y. Those are all factors, things multiplied, as I put in my notes here, okay? So I hope that helps. And then if they're asking for you the factors of 6, it would be 1, 6, 2, and 3. But in algebraic type equations where you're dealing with terms and polynomials, you're going to want to just look at the things that are multiplied times each other. All right, clear all my drawing, select my mouse, scroll down here. Identify the expressions in the following equation here. So if they're asking you, I'm looking at number 10 here, okay. An expression, what was an expression again? An expression was, I told you an expression is like half the sentence. It's what's on one side of the equal sign, okay? So it's like a phrase in English, and a complete sentence has the whole expression, the whole sentence. Expressions are like what's on one side of the equal sign, and sometimes there's no equal sign. They just give you an expression, but it is that everything that's on half of the equal sign is an expression. That's what an expression is. So identify the two expressions. You got -7y plus 2. That's one of them. Okay, if I just draw an arrow here, there's one. And the other expression on the other side is 3y plus 4, which is obviously right here. Okay, those are the two expressions. And again, you have those in your notes. So factors are things squished together, multiplied by each other. Expressions are what's on one side of the equal sign. And then types of polynomials, okay? Polynomials are, we talked about that, various kinds. The three kinds you see by far the most often are what's called if you have three terms separated by plus or minus, that's a trinomial. You have that in your notes. If you have, this is types of polynomials here, okay? If you have just one term, then it's a mono, meaning one. And if you have two terms, you see how they're separated by the minus sign, binomial, okay? So just want to review in your notes, what are the different kinds of binomials and trinomials? Let's look at number 12 here in the bottom of the screen. It says types of reasoning. When we generalize and move from, okay, and we really went over this in the notes last week, I think it was, move from the specific cases to the general one, what type of process that is. And what I did is in our kind of our notes there is I did it like this. You have kind of like all these specific details, okay, about something. And we look at the details on the ground first, and we generalize up to like a pyramid up here to the general theory about what happened, okay? When we do it like that, they call that inductive reasoning, okay? It's inductive reasoning. And the reason why they call it that is because, sorry guys, I have to do something here, let somebody in the classroom. Okay. Because we are inducing something. We are going from the specific, see it says, we move from the specific cases, okay, specifics, the little details, to the general, we move up to the general. So the kind of the general principle, that's inductive reasoning. Conversely, or oppositely, if it said move from the general case, like, this is our general, we'll call it our principle here. Sorry, grab my pen here. If we move from the kind of the general idea here and move down to the specific details, that's deductive reasoning. We're going down. D and down and D and deductive might be helpful as an alliteration to remember. The D, the letter D there. When we're going down from a big theory of something, hypothesis down to the specific details, it's deductive reasoning. Okay. So again, review your notes on that. But that is the difference between inductive and deductive reasoning. Okay. Okay, I'm going to move on. I hope you guys are doing okay here following me. All right, so we're going to get to looking at kind of sequences. The last couple of chapters we're all talking about sequences, guys. What type of sequence was that? Inductive, deductive? I'm sorry. Was it a arithmetic sequence? Was it a geometric sequence? And that was chapter 14 and 15 in your book homework, okay? All right, so the nice thing about your exam is I'm letting you use your notes. So you'll have the formulas all spelled out for you. But So it says using the nth term in question. Oh, I'm sorry, skip 13 here. Consider the sequence. We got a sequence of numbers. The word sequence means you got a group, a list of numbers, and are they in a consistent sequence of some kind, like 2, 4, 6, 8? That would be a linear or arithmetic sequence. Okay. Looking at this sequence here, okay, I've got negative 15, and then I got negative 12, and then I got negative 9. Okay, and so I'm just going to look at what kind of change took place between the 15 and the 12 here, okay? I had to actually add 3, okay, 15, 14, 13, 12. When I say add 3, because if you add 3 to a negative 15, think of it as on the number line here, okay, if this is the number line, okay, and this is 0, okay, negative 15 is way over here, okay, somewhere, okay, it's on that number line. If I add 3 to it, okay, I'm going to get to negative 12. If I add 3 to that, I'm going to get to 1, 2, 3, negative 9, okay, etc. So the question is, what is the formula for finding the nth term? Okay, all right. So a couple of hints I'm going to give you here. This is what they call an arithmetic sequence, okay? It's an arithmetic sequence, okay? Now, in your notes, okay, the formula, wants to know the formula. We gave you a formula for the arithmetic sequence, and it goes like this. You take your starting value, okay, which look at our starting value right here. There's my starting value, negative 15, okay? That's where this negative 15 came from. Plus or minus. Now that's the key, and that's why I'm going to turn it red here real fast on you, okay? When you see plus or you see minus, that's an indication that it's an arithmetic, or what they called in chapter 15 a linear progression. But in this case, we're talking about sequences here, okay? Plus or minus means it's arithmetic. It's going up the same amount. You're adding the same number each time to the previous number, okay? So that's kind of what you want to associate together. If I choose a different colored pen here, when you see plus or minus, you're looking at of a sequence, you're looking at an arithmetic sequence, okay? And the formula is starting value plus or minus n minus 1 times the number you're adding each time, okay? The added number each time. What did this n stand for, okay? This is what term are they asking you to find, okay? In question number 13 here, it says, what is the formula? They're not asking you to find a term. They'll do in the next question. They're just asking you, look at the sequence and figure out what kind of a sequence it is, write out the formula. What is the formula for an arithmetic sequence, okay? So it's n means the term. So if they're asking you for the fourth term, 1, 2, 3, 4, they're asking, assuming you didn't know because it's right here, but they might ask you for the 15th term, or as they do in the next one, the 12th term, okay? Rather than trying to calculate it all out, we can plug it into our formula real fast and figure it out, okay? So the formula is the starting value plus or minus, and then in parentheses, n, which means the term we're trying to find out, minus 1 times whatever number we're adding each time. Okay, this is the number we're adding each time. And we figured out we were adding 3 each time. Okay, and so that's the formula for arithmetic sequence. Okay, moving on to number 14. It says, using the nth terms in question 13, what is the value of the 12th term? So really, if I was writing this, I probably would have rewritten this to using the formula in question 13. What is the value of the 12th term? Okay, so let's plug in our formula. Starting value, negative 15, plus n. The n is the term we're trying to find. I'm circling it on the screen here. So n, in this case, they want to know the 12th term. So I'm going to just draw an arrow here. Whoops, it should go right here, okay? It's right there, okay? So n is 12 minus 1 times the number we're adding each time, 3. 12 minus 1 is 11. By the way, remember the order of operations, do what's in parentheses first, okay? 12 minus 1 is 11, times 3 is 33. So these here, right here, 12 minus 1 is 11, times 3 gets me 33, plus negative 15, okay? So if you remember the rule when you're adding opposite integers, you have negative and a positive, so just subtract and keep the value of the larger of the two, and 33 is plus 33 is larger, so it's plus 18, okay? So that's how we would calculate it. I'm just going to plug it into my arithmetic sequence formula and do the math following the order of operations. Okay, I hope that sort of made sense to you. And again, you can listen to this recording if you need to a couple times, or if there's a certain kind of problem you're having trouble with, you can go, okay, I'm going to listen to that one 3 or 4 times here, okay? All right, let's look at number 15 here. Number 15 asks us this question. It says, identify the following sequence as either being arithmetic or geometric or neither, okay? Now, we just established that arithmetic equals, we're adding or we're subtracting the same number each time. We talked about that, okay? So I'm just going to abbreviate, say number each time to the previous number. Geometric is when you are multiplying okay, the same number times the previous number, okay? Same number. Okay, now that's the difference between arithmetic and geometric growth, or sequences, excuse me. So, and then it says, or neither. We actually have 3 choices here, or neither. You might be going, hey, teacher, we never discussed neither. How would you know if it was neither? I'll show you in a moment here, okay? So let's just look at the numbers. I've got 5, 10, 20, 40. That's the sequence. And they want to know, is it arithmetic, geometric, or neither? Here's how my brain works. I'm just going to talk it out loud. I would look at 5 and go, how did it become 10? How did it get to 10? I added 5. So I'm going to go, okay, I'm going to add 5 each time and see if this is adding, okay? Is this a arithmetic sequence? 10 plus 5 is 15. Uh-oh, I got something different here. I got 20. 20 plus 5 would be 25. This is definitely not an arithmetic sequence. All right, eliminated that. Next one is it geometric, which is where you're multiplying the same number times the previous number. Okay, how did 5 become 10? I must have multiplied by 2. If I multiply 10 times 2, what do I get? 20. Oh, if I multiply 20 times 2, what do I get? 40. Oh, I'm multiplying the same thing times, each time I'm multiplying times 2. There is my multiplier, okay? All right, and if I'm doing the same thing each time, I'm multiplying the same thing by each number in the sequence to get the next number, that is geometric sequence, okay? That's a geometric sequence. All right, so that's why, of course, the answer over here says geometric. Now, the third option, though, how do we know if it was neither? Well, if I added the same number each time and I see, no, that's not working, and I multiplied, okay, 2 times each, and we had a number in here that, like, let's say that this number over here was 23, okay? Just for instance, if that was 23, and I went 5 times 2 is 10, 10 times 2 is 20, but I have a sequence of number of 23. It doesn't fit the sequence. It does not fit multiplying the same number times the previous number. If that happened and you know it's not arithmetic and it's not geometric, then it's neither. That is the case when it would be neither, okay? So just so you know how you would determine if it's neither of the two, then it's got to be a third choice. All right, let's look at number 16 on the screen here, and let's talk about it. In the following table, now I want to give you a hint. You'll see something just like this at the end of your your exam. It's going to spell out for you the formula in the question itself, okay? So follow the directions. Don't gloss over these directions real fast. Okay, well, and then look at the chart here. In the following table, compute, which means to find or calculate or figure out, okay, the y value, okay, you see the x here. I want to just point out that this is the x value and this over here is the y value, okay? All right. So it's saying to compute the y value. So we're trying to find out these y values. So what you will see is you'll see everything the x, and you'll see a 0 here and then nothing over here. These will all be blank. See how they're a little bit darker? Those are answers, right? All right, figure out the y value. It says for a given x value by multiplying the x value by 3. It's telling you right here what to do. Multiply the x value by 3. That's all you have to do to figure out the next y value. Okay. So if you had 0 times 3, you would get 0. 0 times anything, 0. If you have 1, it says multiply the x value here. See this x value. Here's the x value. Multiply this one here by 3, I get 3. In the next sequence, in the next term, if you want to call it, 2 times 3 is 6. Each time I'm going to get 9, 12, 15, etc. Okay? So I'm following the directions to figure out what the next number in the sequence is. Okay? That's just trying to make that really clear here. Okay? All right. Again, if I take my x value here in the next one, in the following table, compute, which means calculate or figure out the y value. They want us to figure out the y value by multiplying each previous value by each y value. Catch that? The y value here, and I really underline is by 4. Okay. So if I take and look at my values here, these are all my x values, all this line, these are the different terms here. And I've got my y values. They're all on this line right here, okay? They're going to give you this and this, but not all these right here. Okay, these will be blank. So let's follow the directions. It says, figure it out, find out the y value, these red column here, by multiplying each previous y by 4. All right. So the previous y was 1 here. 1 times 4 is 4. That's how we got this 4 right here, is I multiplied by 4, okay? And it says to multiply the previous y by 4. Now that I've got 4, that's the y value. Are you following me? I'm supposed to multiply that by 4. Well, 4 times 4 is 16. This is now the new y value. Multiply it by 4, and I get 64, et cetera, et cetera, et cetera. Okay? So that's how I'm going to get my previous y values. So I'm going to say it for the third time. I want this really clear. When you're trying to calculate these be all blank here, okay? If you're trying to calculate it, make sure that you follow exactly what the directions. It spells it out what you're supposed to do. Okay, so read through that nice and slowly, follow it, and you'll do just fine. Okay, having said all of that, let's go on to number 18. Using questions 16 and 17, you see that this was 16 and this was question 17 here. Write a function, which means a formula, okay? And we talked about this in our class, a formula, and in my lectures, which are all on recorded, okay? That's kind of the same idea, if that helps. Write a function to model, which means show the data and whether the function is linear or exponential. All right. Well, let's look at the second question first, linear or exponential. Look at question 16. I got from 0 to 3. I added 3, didn't I? Okay, let's try it to the next one. 3 plus 3 is 6. Oh, 6 plus 3 is 9. Yeah, this is a linear, okay. Chapter 15 starts calling it a linear progression, okay. And I know you're probably going, how are we supposed to remember the difference between all four? You got arithmetic and geometric in chapter 14, and now they're calling them linear and exponential in chapter 15. Well, the nice thing about it is in your question here, it actually gives you the options. It says linear or exponential. So, okay, there it is. I get to pick. They're gonna give me the answers. I have to just pick between them, okay? All right, because I'm adding the same thing each time to the previous value, that's called a linear progression. And by the way, if it was charted out on a graph, which is not, this is my chart here, a linear progression would look like something like this. Yellow, okay, a straight line, okay? It's gonna look like a line. That's why the word linear, okay? In a geometric, I'm sorry, an exponential progression, if I change colors, would look totally different. It would be that really all of a sudden it goes up like a U or something. No, a U is the wrong term. It would look like this real fast. Okay. If we're looking at exponential growth, then we're looking at something that goes like this. Starts a little bit gradually, then it starts going up, and then all of a sudden it just really takes off financially and you're really making money. Okay. So that's exponential growth, which, by the way, when you're talking about percentage, you multiply a certain percent each month or each year added to your bank account or your investment. It starts really taking off after a while. Okay, so anyway, so they want to know, okay, the first one we said was linear, and the second one, number 17, is that, well, we figured out we're multiplying each number by something. When you're multiplying, we're going to call that exponential. Multiplying things, when they get multiplied, they're exponential growth. Okay, so that's linear and that's exponential. Now the question is, they want us to come up with a function, a formula to illustrate this. Okay, guess where your formula comes from? Okay, I will say it for the fourth time here. Okay, your formula comes from right there in the directions. Okay, that's where you're going to get your formula. And the nice thing is on your exam, you're going to have, it's multiple choice. So you'll get to pick the one that seems to make the most sense. And one of them will be the correct formula. So let me show you why. I got, for number 16, y equals 3x, because it says, compute the y value, y equals, for each given x value by multiplying the x value by 3. That's the x value times 3. Y, every y we're trying to figure out equals 3 times x, or x times 3. Same thing, okay? So that's why this answer right here says y equals 3x. Now, I want to clarify something here. Let's look at the next one. It says, we're supposed to figure out what kind of formula this is. It says, in the following table, compute the y, figure out the y value. So y equals, if I wrote it up here, okay, y equals, sorry, this y just got lost in the, y equals, by multiplying each previous y value by 4. So it would be, yeah. So you got 4 times, I'm sorry, multiplying each previous, this is the y value right here. So the formula would be 4 to the x. So if this was see the term here, term 0, term 1, term 3. So 4 times 16 gives me 64. So if it was the fourth term, it would be 4 times 64 gives me the fourth term here. So that's where this x comes in here, it's whatever term it happens to be, okay? So that's, now, just to kind of show you from your notes, the lecture I gave you a formula for figuring out exponential growth, okay? And the formula was it's your starting value, okay, times the multiplier, okay, whatever is being multiplied each time, multiplier, sorry guys. Okay, that's the multiplier. So this is your starting value. That's the formula I gave you for figuring out exponential growth. I said starting value times the multiplier, whatever the multiply, we're multiplying each time. 16 times 4 is 64. 64 times 4 is 256, okay? To the x, this is my exponent, okay? So if it was the second term, it would be to the squared. If it was the fourth term, it would be to the fourth, okay? That is the formula that you have in your notes for exponential growth, okay? Starting value right here, starting value times the multiplier to the x, okay? And that's where this x comes in here as the formula for exponential growth, okay? All right, good news is if that really lost you and you're going, boy, I hope there's not a lot of those on the test, there's only one. Okay, so there's only one that's like with exponential growth. You do have the arithmetic sequence we looked at on the previous page. There's only one like that. Okay, we got to move on for the sake of time here, folks. I wanted to try to clear. Oh, I went longer than I thought I was going to go. Why is that not a surprise? It happens a lot to me. Let's go on to the next one, guys. Number 18. Okay, we talked about that. Number 19. Okay. This one won't be as complex to explain here. it's asking the question, okay, a company has 1,200 clients and wants to gain 15% more clients each quarter. Okay, each quarter they want 15% more. It says use your calculator to complete the table, round your values to the nearest whole number. All right, let me show you what you're going to see here. See all the bolded numbers here? These will not, all of these will not be on your, would not be on your, you wouldn't have these answers, okay? You'd be asked to figure out what these answers are, okay? All right, so it says that each quarter there's 15% growth. All right, I showed you a couple of ways. There's two options for figuring out, you know, if 15% of 1,200. So if I went like this, I could do it this. Option one is to go, I'm sorry, option A, I'll call it. You could go 1,200 times 0.15, which is 15%, okay? And you would get an answer if I did this, 1200 times, what did I say, 0.15 equals. All right, so that gives you, did I do that right? I think I did, yep, 180. All right. Now, to figure out the next quarter, you know, how much it is, I have to add that 180 to 1,200. And that's how I get 1,380, okay? Because I'm figuring out, okay, what's 15% of 1,200? It's 180. To figure out the growth, I have to add that 180 to 1,200, and that gets me 1,380. Now, that's option A. Option B, if I change colors real fast here, is which I also taught you is to do a little bit of thinking up front, and it goes faster, okay? What is 15% growth, okay? Well, 100% is just like this, right? 1.00, that's 100%, okay? So if I wanted to have 15% growth, it'd be 1.15 on my calculator. If I multiply 1.15 times the previous term each time, it will give me the next answer. So there's your shortcut, okay? If 15% growth, if it was 17% growth, it'd be 1.17. That's 117%, okay? If it was decreasing by 15%, it would be 0.85, okay? Because that's less than 100%. All right, it's 15% less than 100. Okay, so those are two, you have two options in how to calculate that out. If you do option A, you have two steps, okay, for option A. But that's how you'd figure out how the next term is. Now, it says to round it to the nearest whole number. So whole number, just so you know, is if I had 2.97, okay, can you figure out what would that be to the nearest whole number? Whole number is this. This is a whole number. This is these are decimals. So that would be 3. That would be the nearest whole number, okay? So you might have 1,825 point something, 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 rounded to the nearest whole number, okay? The number to the left of the decimal. All right. So it says table around. So it gave you 5 quarters. So you'd only have to do 5 quarters. All right. That brings us to our very last question. Okay. Very last question. And then I will take questions if you have any questions for me. So scroll, come on, scroll. There we go. All right, it says here, now, get my pen back. It says the function, which is the formula, okay, the function that models the data in question 19 is the t, this is the term, okay, or the quarter. Let's see if I can move this out of the way here. See if, see how I've got the quarter, oh, it just disappeared on me here. But quarter 1, quarter 2, quarter 3. So that'd be the term, okay? How much money they made that quarter. The term is equals starting value times the percent to the, and this Q has to do with the quarter, okay? The quarter was first, second, third, fourth, fifth, okay, quarter. So that's the exponent. Remember that little Q up there, see how it's up above a little? That's the exponent. That's like That's like 2 squared equals 4 is 2 times 2. So remember that. And by the way, I mentioned to you guys last week, you have a little tab on your calculator on your if you have the TI 30XS, it's on the far left, kind of in the middle. It says x squared, and that's it looks like this. It says x squared. Okay, that's if you want to square something. So if I put 6 and then I pressed that x squared thing, it would square it. Okay. But you also have right above that. So if you want to write this down, okay, right above that key, you have something that looks kind of like this. Okay, it looks like this. So it's right above the x squared. In fact, I should just put it above it just so you can see. It's a key that looks like that. Okay, so what you would do is if you wanted to do something to the, say it was the 12th term or the 9th term or something here, okay? So you would have 1.15, this is 115% to the, say it was the 9th quarter, okay? So you're doing it to the 9th. If I put 1.15 in my calculator and then press this key right here, okay? And then press 9, that will give me to the 9th. I'll say that again. If you've got a square key, your square key looks like this. It's on the left side of your calculator, and it means whatever number, you press that number and it'll square it. Okay, times itself once. Okay, but if you have something to the 9th or to the 4th or to the 12th, you put your number in and then you press this key, which is right above the square key, and then you press the square, how many you're doing it, the power you're doing it to. Is it the 9th or the 12th or the 10th or whatever? And that will calculate it out for you instantly, okay? All right, having said all that, it says the function, this is the formula right here. Using this formula, how many quarters will it take to surpass the company's goal? They have a goal of making 4,500 clients in a quarter, okay? And I'm sorry that this thing is not cooperating here. I'll try one more time here to move this out of the way here. Maybe that helps a little bit. Move that out and this up. Okay, it helped. So we've got a quarter here. And so they want to know how many quarters it says. It's asking how many quarters is it going to take? How many quarters will it take to surpass the goal of 4,500 clients? All right. So let's just think for a second. They want to know how many of these quarters. See, these are the quarters right here. Okay, I'm circling the screen. I know at the 5th quarter, they had about half of that amount, didn't they? They got 2,414 clients. That's the 5th quarter, okay? And they want to know how many quarters will it take to get to surpass the goal of having 4,500? Well, that's about twice as much. So I'm going to guess and say, what about 9 quarters? What would it be if it was 9 quarters? Okay. So I take my formula, 1,200 times, this is 150% growth. Okay. So 1.15 to the 9th. Okay. And again, this is what I just showed you. You press that button on your calculator. And this is the answer I get right here. After the 9th quarter, I have 4,221. Is that enough? Their goal was 4,500. No, it's not enough. Okay. So let's try it to the 10th term, to the 10th quarter. Okay. 1,200 times 115% to the 10th. And this would be the 10th quarter. And sure enough, I get 4,855. I'm looking at 4,500. Hey, that's more. It would be 10 quarters. It would take me 10 quarters. I'm not talking about money here. I'm talking about periods of time, 10 quarters of time. Like we have 4 quarters in a year for school, fall, winter, spring, and summer. So it would take 10 quarters to reach their goal, surpass their goal of 4,500 clients. Okay. So in review, all we're doing is they give you the formula and they ask you to figure out how many quarters is it going to take to surpass this goal right here. Okay. So use your calculator, punch things in the calculator, use this special key that I just got through talking about you to figure it out to the 9th or to the 7th or whatever. And that will give you answers that will help you figure out which one surpasses that goal. Okay. And so that's why you have an answer given for you 10 quarters here. All right. That is everything you need for the final exam. A couple of announcements, and then I'll take questions, and I'll turn off my recording and take questions. So announcement number one is your final exam is due by tomorrow night, which is Tuesday night, by midnight. So you can take it tonight, you can take it tomorrow morning, tomorrow afternoon, after work tomorrow. Additionally, all of your wall map homework, okay, that's all the stuff that's online through chapter 1.14, not 1.15 in wall map only. So all of the odds are due. And then I will, on Wednesday, I will start adding everything up and put a score in Canvas for all the wall map. Your score will be in there for exam 3. Hopefully, all of your homework should all be turned in. So that should be all put in wall map. So we'll have a pretty good idea what your grade is real fast. Okay. And so that's due, everything is due by midnight Tuesday night. So any book homework, let's say you still have a chapter and you hadn't turned that in, turn that in. You'll still get points for it through tomorrow night at Tuesday night at midnight. Okay. And that would be the official end of finals, end of the quarter. And that should be it. If you're not registered for your next class, be sure and do that real fast so you actually get a spot. Otherwise, these spots start filling up and you could end up having to wait a quarter. All right, and that is it. So I'm going to try to turn off the recording. There it is. Stop recording.